Alright, so today what we're going to be doing is that we're going to be integrating the natural log of x dx. So basically, we look at natural log of x, it looks like we can't do much of really any substitution. We know that the derivative of natural log x is 1 over x, but that kind of doesn't help in this case, really. But here's one thing I'm going to do. Alright, so what I'm going to say something. I'm going to say x is equal x is equal to e to the u, right? And I'm going to say dx is equal to e to the u du. Right, I just differentiate on both sides, right? Easy. So let's see here. I said x is e to the u, dx is equal to e to the u du. I'm going to plug in e to the u in place of x, right? And then plug in e to the u du in place of dx. So I have the integral now of natural log of, well, it's not x, now it's e to the u, times dx, well, it's not dx anymore, it's times e to the u du, right? And immediately we see something, right? I mean, this is kind of the whole point of the substitution. We get natural log of e to the u, that cancels out, and we get u. So we actually end up with the integral of u e to the u du. Now, it didn't look like it might not look like the situation got any better, but you see, this is an integral that we can really easily do by integrating by parts, right? So we could just differentiate u and integrate e to the u, right? And integral of e to the u is easy, it's just e to the u, right? So to do the integration by parts, to organize everything, I'm gonna use the di method, right? So di, I'm differentiating u. Well, I should get my plus and minus, plus minus, plus minus. So I'm differentiating u, I'm integrating e to the u, right? So I differentiate u, I end up with just, 1. And I integrate e to the u, I just end up with, e to the u. Now I end up with, so basically, I got these terms, right? So u times e to the u, and with u e to the u minus, and then the integral, right? Minus integral of, e to the u du. Hopefully you can see all this. Yeah, you can see all this. So we end up like this, right? And then we know what integral e to the u is. We just did it. That's just e to the u. So we end up with u e to the u minus e to the u. Alright, so that's a lot of u's. We should get a final answer in terms of x now. So we said that x is equal to e to the u, right? So u is equal to natural log of x, right? So we got u is equal to natural log of x, right? And then we'll just plug in natural log of x into the stuff right here. So we end up with natural log of x, that's u, times e to the natural log of x minus e to the natural log of x. We'll do simplification. I'm going to hold off on the plus c for now. We do the simplification. Well, we look at e to the natural log of x, that's just x. So we end up with x ln x minus e to the ln x, that's just x. So we end up with x ln x minus x plus c, also known as integral of natural log of x. So yeah, basically that's really it. It's so natural log of x, its integral is integrating it. It's it doesn't look like we can do much, but we can turn into a really easy integration by parts problem. So pretty cool. And stay tuned for more cool stuff like this.